Question 14 reads, how many integers greater than 20 and less than 30 are each the product of exactly two different numbers, both of which are prime? This is a factors problem, and to solve this problem, we're not actually going to employ any math tricks or magic here. We're actually just going to look at each of the numbers between 20 and 30. Now, a lot of times, if you're inclined to use a brute force method and look at every number in a problem on the SAT, it's usually not the right method, but a good indication that this isn't a problem is that there's not that many numbers to look at, just 21 through 29. If you found yourself suddenly trying to make a decision about 30 or 40 numbers, then that's a good indication that you're not doing the right method. But 9 numbers is a reasonable amount to have to look at, so we're on the right track. So since we're looking at the numbers that these numbers are a product of, and they're going to be prime, then we're looking at the prime factorization of these numbers. So we want to know how many of these numbers have a prime factorization of only 2 prime numbers, and they're both different. So let's get started. 21 is 7 times 3. Those are 2 prime numbers, and they are both different, so that checks out. 22 is 2 times 11. Those are both prime numbers, and they are both different. Check. 23 itself is prime, so it's not the factor of 2 prime numbers. 24 is 2 times 12. 12 will have a further prime factorization into 3 and 2 squared, so that's too many prime numbers. So that's out. 25 is 5 times 5. Those are 2 prime numbers, but they're the same prime number, so that's out. 26 is 2 times 13. Those are 2 prime numbers, so that checks out. 27 itself is prime, so that's out. 28 is 2 times 14. 14 will require further factorization into 2 and 7. So again, we have too many numbers, so that's out. And 29 itself is prime, so that's out. So we're left with only 3 numbers, 21, 22, and 26, that fit the requirements in the problem. So the correct answer is D, 3.